Hi, I'm Jim Hanley, and it's the 28th of March 2022. Welcome, David Wolfson, on behalf of our respective departments and on behalf of McGill.
Jim, thanks very much for inviting me to this interview.
Very good. Yeah, so I'm hoping it's a chance to hear your views on the principles you've lived by and your opinions, which I know you have many of. And I know you impart them in the classroom and to your trainees and with your colleagues and collaborators. So I'm hoping to hear some of them. And also, of course, I want you to reflect a little bit on your, I think it's 47 years in the profession. Is that right?
That's correct.
Yeah. From 1974 to 2021. All spent at McGill.
That's right.
Yeah. Of course, besides looking back, I also want you to look ahead and see what's in store for our profession and whether you have any words for the next generation coming through. But before I start with your beginnings, I want to start a little bit with, you surprised me last year when I heard that you were going to retire. Had you planned it?
No, I always said to people, including my wife Tina, I'd always said, one morning I'll wake up and say I'm done. And that's what happened. I think it was hastened by COVID and absence from the campus. Teaching was no longer as much fun, no direct interaction with students, office hours through Zoom. It wasn't fun anymore. And so that's what happened. I woke up and I said, I'm done. And I must say I haven't regretted it for one moment.
Yeah. And obviously, going back over the 47 years, it must have been mostly fun, was it, your profession?
Oh, absolutely.
Yeah.
I think the most fun thing about being an academic is that you get to learn something. So when you get to learn something as an academic.
I see.
You learn from your students. You learn from your collaborators that you do research with. And that, I think, is the most interesting part, is learning new things.
I have the same sense. That's the reason I don't want to retire as well. Yeah.
And also reveling in outstanding students. And being able to look at a class and saying, several of these students are much smarter than I am. And I never had a problem with that. Why should they not be?
Yes. That's true, yeah. So before though, I want to start with your entry into the profession itself, but I want to go back a little bit further to your entry into the world itself. And a little bit about what I call nature and nurture. So first you were born in 1946?
That's right.
In
Johannesburg.
In Johannesburg.
Yes.
And did you live there until you left?
Well, we lived there until I was 6 years old. My father was a printer.
Yeah.
And then wealthy relatives, a wealthy uncle in Durban said to my father, well, why don't you move to Durban and work in one of my furniture stores? And so that's when we left Johannesburg when I was 6 years old, and we moved to Durban.
I see. So your father was born in South Africa?
He was born in South Africa.
Yeah. Your mother?
My mother was born in London.
Oh, yeah?
Yeah.
And how did they meet?
My mother came out to South Africa on a trip. I think she must have been invited by a friend or something, and she met my father on a trip to South Africa. And then she went back to England, and my father wrote to her, and I guess was trying to court her, and she didn't reply, and he was annoyed. And why was he annoyed? Well, my mother said, you didn't send an address that I could write to. Anyway, they eventually made contact, and she left England in 1939 and came out to South Africa to marry my father, and she was at sea when war broke out.
Yeah.
So she escaped. Well, she escaped, yes, she did escape. But it was very tense times, because at that stage merchant ships were being sunk in the Atlantic.
Interesting. Yeah.
So
And both of them came from Eastern Europe, both sides.
both sides. So my father's side came from Lithuania. There was an influx of Lithuanian Jews, I guess, at the end of the 1800s into South Africa, largely uneducated people.
Mm-hmm.
And my mother's side was Polish Jews. And my mother's parents,
Yeah.
they arrived in England around about 1900, maybe a bit before. And so...
And your mother's father was I was quite impressed to hear your story of him.
Yeah, I'm sure he didn't speak English when he arrived in London. And he managed to put himself through high school and then subsequently through university, got a BA degree in 1909 from King's College, London, and became a school teacher and at the Jewish Free School, which is apparently a very good school. He was a remarkable person.
And your mother then went out, married your father.
Yeah, she left school when she was probably, 16 or something like that. My father left school when he was about 12 or 14. He was very young, and because the family was so poor, he had to go out and work.
And then you moved to Durban, and things
Then
got a
we-
bit better.
Things improved. My father had a profession, but clearly they were never going to be wealthy. But I think once they got to Durban, and eventually upper middle class, I would say.
I get the impression from you that it was a very happy childhood for you.
Absolutely.
Yeah.
To a large extent, because of the wealthy relatives that we had, we had access to everything. We even watched hockey, subsequently ice hockey.
Is that right?
And subsequently found out that there were expatriate Canadians that were playing. But we went to the circus that came to town. We saw these famous performers, Victoria de Los Angeles, Trini Lopez, I don't know if you remember, Tommy Steele. We went on trips to the game reserve. We went to beach cottages. We had access to everything because my relatives were so wealthy.
I see.
They changed their cars every year or two for Rovers, Jaguars, even.
Who was in the family? How many siblings?
I've got I've got one brother,
Okay.
but it was on my father's sister's side. That was the wealthy side of the family,
I see.
and so we lived a very privileged existence. And it was a mix between England and the United States. We had tea at 4 o'clock in the afternoon, tea and cake. That was a tradition. But on the other hand, many of the comics, American comics, we avidly read. The Hardy Boys, we avidly. So South Africa was a strange mix in those times of the U.S. and England.
Did you have maids?
Absolutely, practically every white South African would have one or two people that worked in the garden, one or two people that worked in the kitchen. But these people, of course, could not sit on the same bus bench as whites. There were signs that said whites only. If they went to an industrial or an agricultural fair, blacks and whites had to go through different entrances and then merge after they got in.
Is that right?
Yes.
Yeah. And school, you showed me one picture, and we'll see it later, of your school, your class.
Yes.
Sounds like you had a very good primary education.
Actually, it was exceptional. There was a school called Sherwood Government School, and it was exceptional in at least two senses. The principal of the school was a Miss Frank, and that was a woman. It was unusual to have a principal as a woman. Secondly, we got to wear safari suits in the summer with sandals, whereas all the other poor kids at the other schools wore grey shorts, white shirts and ties and shoes. So in that sense it was exceptional. But Miss Frank was an amazing educator. She read us all sorts of advanced material. It was...
and already in primary school, where it was your passion for sports coming through already by then? Or
Absolutely.
When did that develop?
Well, my father was always passionate about sports. I mean, we'd have conversations about the rugby players of old that he remembers and the cricket players of old. And he was a keen table tennis player.
Yes. And so you moved into cricket and rugby were your two main sports?
Cricket and rugby, because at that time soccer was not big for whites in South Africa. In fact, if the rugby coach found out that you had played soccer on a Sunday over the weekend, he wasn't very happy. So it was.
And were you big for your age, and
No.
did that help, or it doesn't matter in cricket? I guess it doesn't matter.
No, cricket doesn't matter, but rugby, I played flank, but nowadays I would have been too small for flank. I was sort of medium height, but that was in those days it was sort of okay.
Yeah, and your passion for sports, I know it from the years here.
Yeah.
You would be playing squash several times a day, I think, if you could.
Well, absolutely. So, actually, I played some squash. Squash was something that I learned late. I played as an undergraduate at the University of Natal. I started playing squash, and I used to play with Trevor Goddard, who was one of the great all-rounders of cricket of South Africa, and he gave me a squash racket because he was sponsored by Gray's, the sports equipment manufacturer. I used to play with him, but when I got to graduate school at Purdue, I started to play squash fanatically.
Yeah.
I mean, every day. There would be no life without it. And then when I got to McGill, maybe even more fanatical. I'd sometimes play twice a day. And if someone cancelled on me, I think that the world would come to an end.
And what was I going to say? I lost my track now. But anyway, so sport was central to your being by the time.
Yeah. I mean, I played cricket. I mean, cricket was a serious thing. I thought I could never live in a country where there was no cricket. We have photographs of me sitting at the dining room table with a cricket ball sitting in the front of the table. I mean, the family's sitting there, but the cricket ball. And I scared my parents because I wanted to become a professional cricketer. And I was.
You mentioned to me several big names in cricket that were not classmates that you knew and played with.
Oh yes, there's a guy, Mike Proctor, one of the great cricketers, one of the world's great cricketers, all-rounder. He and I were the same age, and I remember we went to play against his school. He went to a private school when I was 12 years old. I remember exactly where I was fielding, and Barry Richards, another great cricketer. These guys' careers were cut short by apartheid because South Africa was ostracized.
Yeah.
And they were kicked out of world cricket. And Lee Irvin, a lot of these guys played for South Africa, and I played with them. Of course, nowhere near in the same league.
Mm-hmm.
And Jim, I believe that if you are in a certain field, it could be academia, it could be sport. If you are in that field and you know that field, you know where you stand. You know where you stand. So getting back to the squash again, I played squash fanatically. I became an A player. When a friend of mine who'd become an A player, you become an A player if you win a B tournament and you're forced to play in A tournaments. A friend of mine said to me, David, welcome to the A consolation.
Oh.
And that's exactly what happened. My first tournament match, I played a guy who was a good A player. I just didn't win a point. It was 9-love, 9-love, 9-love. And so I realized that where I stood, I was good for someone off the street, but for squash players, nothing. The same with cricket. Rugby, I was never all that good. I was okay. I played for the first 15, but cricket, I was pretty good. And it's the same with academia.
Yes, it's important.
You have to understand that
yeah.
maybe you're good, this is what you can do.
Yeah.
It doesn't mean that you shouldn't have aspirations, but you should know where you stand.
Yeah, good point. And in high school, there was even more probably. This was mainly in high school that the sports competitions and teams you played on.
Yeah.
Yeah.
I mean, that's you probably were aware, the British tradition, a healthy body, a healthy mind.
Absolutely.
And everyone had to be out in the sports field in the afternoon. If you didn't go to rugby practice or cricket practice, and you weren't playing tennis or doing track and field or something, you had to have a note from home why you didn't go.
You had army service that was compulsory?
Yes.
How was that?
Terrible.
What was wrong with it?
Well, I came from an enlightened liberal family, and I was plunged into this racist, fascist environment, which was the army in South Africa at that time.
White and black, or white only?
Just white.
Just
of course, white. Absolutely. Of course, who was cooking the food and so on were blacks and doing the cleaning. But of course, the army was white, and the purpose of the army in South Africa in those days, to a large extent, was to keep a lid on things.
I see.
And almost everyone that I encountered in the army was blatantly racist.
Yeah. So you mentioned your liberal upbringing.
Yeah.
Your parents sounded like they were quite cultured. They brought you to music and.
Absolutely.
Yeah.
That's again remarkable, considering, particularly my father. My mother maybe slightly less, because her father was educated, and she grew up with some exposure to culture. But my father, completely self-acquired. He was a voracious reader. They took us to concerts, the ballet, all sorts of cultural events, sporting events. I remember, you probably don't remember Chris Chataway, the great British runner. We went to see him when he came out to South Africa. Yeah, we had it privileged. Even stock car racing we went to watch, and professional wrestling.
So it's like school is very boring compared to that. So in undergraduate studies, what did you go into study mathematics, or what happened?
All I know is one thing, is that when I was in the army, first of all, we had an amazing, personally had a huge influence on me, mathematics teacher at high school, Hector Commons. And he was amazing because he knew his subject. In those days, the teachers, I didn't even know if they had degrees in mathematics, but he had a master's degree, and he really knew his oats. Nowadays, the way he taught would be disapproved, I guess. We were assigned homework, go home and learn this theorem, Pythagoras' theorem. Mm-hmm. And then the next day you were expected to reproduce the statement of proof of Pythagoras' theorem. If you got it wrong, maybe that would be your last chance for the boys. And if the next time you also messed up on one of these things, you got caned. Yeah, he was the vice principal. You went to his office and you were caned.
He didn't do it himself in class?
Oh no, not in class.
Oh yeah.
Oh, I did get caned in class once by the science teacher, because he spilled mercury on the front desk, and a couple of us ran to the front and we brushed the mercury into our hands.
So you liked chemistry, if I remember right?
I was fanatical about chemistry. I was going to do chemistry.
Oh yeah.
Oh, I had a lab upstairs in my room with all sorts of fancy equipment and dangerous chemicals.
The agents and so on.
My father sent someone from his store to an industrial chemist and bought and was prepared to get these chemicals for me, concentrated nitric and sulfuric acid. Never got cyanide, potassium cyanide or sodium cyanide. I was scared of that. But sodium and potassium, which had to be stored under oil. If you throw it on water, it races around and explodes. Never got phosphorus, which also has to be stored under water. So, but had all sorts of dangerous things in my room. It was a little lab in my room.
What happened to your aspirations for chemistry?
So, within 6 months, so I was going to do chemistry. When I got to university, the standard approach was that you take 4 courses in the first year, 3 in the second year, and then 2 in the third year. And the courses that you maintained over 3 years were called your major. So I was clearly going to major in chemistry. And within 6 months, I hated chemistry. It wasn't fun standing in the lab doing titrations, and then just before you're about to read your results, the burette leaked and all your acid landed into the beaker and destroyed your titration.
So it wasn't a question of your knowing your place and your rank in chemistry. You were good enough to do it.
I was good enough to do it, but I just hated it. It wasn't quite the same as doing chemistry at home.
I see.
When you had to do it under controlled conditions. I mean, we used to do crazy things. We used to, you were given things to analyze for your weekly assignment or something like that, powders and things, analyze these things. We used to use all sorts of devious means to find out where they were taken from the shelf and what it was and what our friends...
Yeah, we used to borrow from the ones who were in the lab before.
Yes.
Yeah, exactly, in physics. I started out hoping I'd be a physicist and gave up for the same reason. Yeah.
Anyway, so chemistry was very quickly out of
And
the...
then mathematics was always strong, I guess.
Yeah, so I was, as I say, we found this teacher, this high school teacher who was incredibly inspiring. And there were a lot of kids in the class who were smarter than I was, I think, in mathematics. They didn't do anything. But one of the things that I had is an inquiring mind. I always was asking why. And when I went into the army, the book I took with me to read was Teach Yourself Calculus.
Oh.
Even though we did calculus at high school, extra calculus. So I must have been interested in mathematics at that stage. But I wasn't going to be a mathematician. I was more interested in chemistry before I got to university.
And how did statistics come into it then?
Well, as I said, you start with 4 courses in the first year. Second year, you dropped 1. And third year, you dropped another. Since I hated chemistry, there remained 3 courses. And the 4 courses I'd started out with were mathematics, applied mathematics, physics, and chemistry. Well, so I was left with applied mathematics, physics, and mathematics. But the physics department was a bit of a joke. The guy who taught first year physics, they said his research consisted of putting plates out on the lawn in the evening and looking for radiation and collecting them. So, and I did not like physics at all because of the department.
Yeah.
So I was stuck. I only had 2 courses, and I had to collect 3 courses. Well, statistics to the rescue. Because mathematical statistics was only a 2-year major. You only had to do it for 2 years. You weren't allowed to take it in the first year because it had math 1 prerequisite.
Yeah.
You had to have the mathematics to do mathematical statistics. So that's how I came to do statistics. It's because I hated chemistry and the physics department was lousy.
In the statistics courses, was there anything applied or anything that was that we think of as attractive in that sense? Or was it seen as a branch of mathematics?
It was more mathematical. It wasn't really applied. It was difficult to be applied. We had these hand calculators.
Did you? Right. So
Yes.
it was a bit not fun, really.
And eventually there was a mainframe, a 16K mainframe.
See. And when you did a master's, but when was the work? Was you were working for a year somewhere? Was
Yeah.
that between the master's and the?
No. So I did an undergraduate BSc,
Yeah.
and then a BSc honours.
Yeah.
The fourth. That's again the British tradition. You can do a 4th year, and then it's called the honours degree. It's an extra year. And then after that, I did a master's degree. And when I finished my master's, which was a thesis,
Okay.
I went to work for the South African Chamber of Mines as a statistician
Oh. Okay.
in Johannesburg. It was for me, it was a bit of a joke.
Why?
It was a joke because I think if you walked along the halls and looked into the offices, people were sitting with their feet on the desk reading the newspaper. They sponsored lunches. Lunches were incredibly cheap. They had squash courts. Your mind, and if you were an engineer, you were taken more seriously. But as a statistician, no one really monitored me. No one could really care that David Wolfson was doing useful work.
I see. And they went by their wisdom and their gut feeling about how to do things in mining?
Yeah. I think one of the projects I was on how fast fuses burn and so on for the...
I see. So not a great respect for statistics itself.
There was a person who I never got to meet, a guy by the name of Sichel, S-I-C-H-E-L.
Yeah.
And I think he worked for the Chamber of Mines. And he used to go down into the stopes. The stopes are those narrow tunnels where you stoop down, sometimes 3 or 4 miles below the surface of the earth. Humidity's 95% humidity, temperature over 95%, because he believed that as a statistician, you should see how the data are collected.
Yeah. Did you go with him?
No, I never went down. Thank goodness I never went there.
I see.
I mean,
I have that same sense. I got brought to see the throat cancer, and the guy said, "You got to measure this thing if you're going to ask me how it is.
Yeah.
You have to measure it yourself," and that scared a lot of people off. So and then, so you didn't stay. Did you have in mind that you might go to graduate school at that point already?
I don't think so. I think if I had landed a good job as an applied statistician, I probably would have continued in it.
I see. But it was the lack of challenge, I mean, is what stopped you, right?
Right.
Yeah. And then you started looking to go
and I only applied to 2 schools. I applied to Cornell, and I don't really remember why Cornell and Purdue. Purdue I remember.
Yeah.
So that would have been maybe a bit of a bizarre choice to people who don't know North American universities. But we had a textbook on analysis by Goffman and Pedrick, and they were at Purdue.
I see.
And Purdue is primarily known as an engineering school, but nevertheless, its statistics department was very strong, maybe top 6 or 7. They had some famous people in the statistics department. Anyway, so I'd done my master's degree in thesis on something to do with time series. And there was a guy, McFadden, at Purdue in engineering, electrical engineering. And so I wrote to him and said, I was interested in doing a PhD. And because he had worked in not time series, but stationary stochastic processes. And he wrote back and said that he was not in good health, that he was ill, and he suggested that I get in touch with his colleague, Marcel Neuts, N-E-U-T-S, in the statistics department. And I wrote to Marcel, and he got me into the statistics PhD program at Purdue without doing the GREs because I was too late. So maybe I was lucky.
Yeah. And when you got there, did you realize, were you well prepared already?
Yes.
Compared to the other students?
Yes, I think I was well prepared.
Yeah. Did you still take a lot of courses there?
Yes.
Yeah.
Yes. I mean, there was a large offering of courses. The department was about between 25 and 30 faculty.
Who were the big name that I might know?
Well, the big person of conversation was Herman Rubin.
Yes.
There was a guy, Glenn Baxter, who is mentioned in Feller's book frequently, sadly committed suicide. Shanti Gupta, Bill Studden in optimal design. Jim Berger arrived there as a new faculty member just after I got there. David Moore was there.
Yeah. Was he interested in teaching then already?
So David Moore had done, I think he did his PhD at Cornell, and he used to teach courses that other people made incomprehensible. So Herman Rubin, I don't know if you've heard of Herman Rubin. Herman Rubin would teach a course in large sample theory, which was completely incomprehensible to even faculty members. a year or two later, David Moore would teach the course in large sample theory that was entirely comprehensible.
But David then went on to write some great selling books.
Oh,
for undergraduates.
Oh, absolutely. But he knew the advanced stuff as well. Oh yeah, he taught the course that I took from out of Blackwell and Gershik on game theory and decision theory.
Oh wow, yeah, because he produced that program or that TV series called Against All Odds. That to me, I still go back to for TV people. He had a very clever way of being applied. So he was an all-rounder.
Yeah, he became more interested in that undergraduate stuff later on. But when I was at Purdue, he wasn't teaching that. He was teaching advanced courses.
I didn't know that side of it. Yeah, because I adopted his books early on here. Moore and
McCabe.
Yeah,
George McCabe. Yeah, George McCabe was a student of Herb Robbins.
Okay.
And he was a fairly new faculty member at Purdue as I was finishing up. But I think he also became interested in undergraduate. He ran the consulting service actually.
Now, so you were there from 70 to 74.
That's right.
So now it's coming to the end of your time.
Yeah.
And you're looking around. What had you anything in mind of what you wanted? You wanted to be an academic.
Yes, I at that stage, yes, I wanted
you didn't want to go back to South Africa.
No. Because my parents had always told my brother and I, leave this country. This is no place to bring up your children because of apartheid. And so my parents always encouraged us to leave. So going back to South Africa was not considered an option.
Did your brother leave as well?
Yes, my brother left eventually as well.
Yeah. And did you ever try to get them here, or it was all a matter of you going back to visit them?
My parents, I mean.
Yeah.
They sort of hung on until it became too late for them to move. That's, I think, what happens with a lot of people. They delay their departure. You could only take a certain amount of money out with you, and eventually they got stuck there.
Your mother, there's very long genes on your mother's side, right?
Not on my mother's side, my mother.
Only her?
But her siblings died relatively young, heart disease rife.
I see. But she lived to
103. 103. She lived to 103.
Yeah. What did you just say about being forgetful or memories?
Well, yeah, she said to me, David has a good memory for some things. I mean, when I went to visit her, I think I was with Tina at the time. She was in this sort of senior citizens hotel residence type thing. Yeah. And twice, she would give me a key when we left the apartment. Twice I walked away and left her sitting outside in her wheelchair, sitting outside her apartment. I'd forgotten that I had a key. And remarkably, she just probably shrugged it off. That's David.
So you're looking around, so you're in North America, you're finishing up there. Did you look in the US for jobs, or what brought you here to Montreal?
Yeah, I had what is called a J visa. And according to the US traditions, or the US law, if you had a J visa, when you finished your studies, you had to leave the US for 2 years. And I think maybe even go back to your country of origin, but they couldn't enforce that. So they had just made sure that you left after 2 years, because that was an agreement, supposedly an agreement between countries that needed skilled people to return. So I had to leave, as far as I'm concerned, would be more convenient, instead of I had to fight it through lawyers, leave the US. Interestingly, just the other day I was looking through some documents, and I found a letter from the US, from the South African government, and I asked them about this J visa and getting an exemption and so on. They said they don't know anything about it. They don't care if I don't come back. I was sort of offended, but they claimed to be completely ignorant of this J status. Yeah. So I applied to 2 places actually. I don't recall applying to others. I applied to Cornell. I went for an interview and didn't get the job, and to McGill, and got the job.
Who was here at the time?
George Stein,
Was he who was chair? Or the chair?
Rosenthal was chair.
Okay.
Eddie
the library's named after.
Eddie Rosenthal was the chair.
Yeah. And how big was the statistics department here at that time?
There's no
the division. I mean, of it.
The Department of so it was the Department of Mathematics at that time.
I see. Yeah.
We had altogether maybe six statisticians who were regarded as a bit of a burden and not really looked well upon, which is one of the...
And how was there as much teaching of statistics courses throughout the campus then as there is now?
Not as much as the proliferation of statistics courses, but they were taught around campus. Biometry taught statistics. Geography had a statistics course. Psychology, Jim Ramsey. They not really advanced courses, but there were a lot of these introductory non-calculus statistics courses around campus at that time.
Stuart, you were there behind. David met his wife as a student here. I'm going to surprise him now. I don't see me blushes.
Well, all right, so I don't care.
I didn't tell him I was going to ask this.
Okay, so I'll tell you about that. So Tina was a student in my class.
Yeah.
Now, these things, of course, what I'm saying now would never be allowed nowadays.
Well, I want to hear the accommodation you made.
So Tina was a student in my class. After the course finished, I asked her out. So she was never a student while in one of my classes, but still considered conflict of interest.
Yeah.
Subsequently, Tina became a graduate student, and she was a marker for me.
Yeah.
Maybe a TA or marker, I can't remember exactly.
Yeah.
For Math 203, which is our service course, non-calculus course like your 607, maybe it's changed.
Yeah.
So one day, so Tina turned out she was a marker for the course that I was teaching. So one day, for some reason, I got delayed, and I didn't get to class on time. And Tina would come to my class just to see what I was doing as a part of her duties as a marker. So gets to class before me. She's standing outside the door, and one of the students says to her, "Is your father coming today?"
Oh!
So she said, "Not my father, it's my husband." The guy laughed. He said, "No," because she's 9 years younger than I am.
She's married. You were married at that point.
We weren't married at that. No.
I see. So you're right. Today, what the rules would be about,
Or maybe we were married. I can't remember.
Yeah. Interesting. Yeah. But now it happens. But now the university probably has rules about.
Yes, I don't think that would be considered acceptable, even if you weren't teaching. I don't think so.
Oh yeah.
Yeah, I think that fraternization with students is not considered at that level. Is not considered appropriate.
Yeah. Anyhow, it's but. More to the point now, there's a next generation of statisticians. Your son now, Tina and you have a son who has continued in the tradition, right? Did he came through here?
Yeah, he did. He did an honors degree in math and computer science.
Yeah.
Because there was no statistics in computer science, and he was very keen on doing microbiology. And we said to him, "Do you really want to do 5 postdocs?"
Yes, no job at
no job at the end.
Yeah.
So he got to thinking, and his next thought was, to do. I said the trick is to do something in which is you're sort of interested in, but something which also you're going to be rewarded for.
Yeah.
So maybe bioinformatics would be a good choice for you. And he spoke to biologists and who said, it's best that you learn the mathematics, statistics, and computer science first, and learn the biology on the side, rather than vice versa.
Yeah.
So anyway, he completed his degree, and he sort of, I don't think he wanted to do epidemiology or statistics because his parents were doing that.
Well, that's why the reason I'm asking is I couldn't get any of my kids to follow along after me, so I'm curious how you...
But he changed, and he decided he wanted to do statistical genetics.
Okay.
And so he applied to a bunch of graduate schools in biostatistics. I don't think he applied to any statistics departments. And he got it into these places.
Well, University of Washington was very good in statistical genetics.
Yes, Elizabeth Thompson was there.
Yeah.
So he eventually chose Washington. Harvard, interesting thing, Harvard he was not interested in because they were doing mostly work on HIV/AIDS, and it just wasn't particularly interesting to him to do that. They reminded him of that, by the way, when he went back subsequently. You turned us down. And he went, that's how he went to Washington because of his interest in genetics, statistical genetics. Well, like with me in the chemistry, in the statistical genetics, within 6 months he didn't like it. He thought it was far too specialized. And so he ended up doing his thesis. Part of his thesis was on HIV/AIDS.
Is that right?
Yes.
Yeah.
With Peter Gilbert.
Yeah.
So you don't know where you'll end up.
Yeah. That's true. It's true. But I honestly, I think biostatistics. My son has since said to me, that you seem to have an enjoyable career. Yeah. I think it's interesting.
One little quick story. So when Julian came to give a talk in our department, the first thing that he said to the audience was, I guess I'm what you get if you cross a statistician with an epidemiologist.
So, now, what were your own favorite topics to teach here, and what levels did you like to teach? If you you hadn't much choice about which courses you were given, I imagine, or did you?
Oh, we've always had.
What was the tradition? Yeah.
So the tradition on, certainly in my memory, I don't recall exactly the very beginning when I first came.
Yeah.
But certainly I have recollection of the way the courses were assigned is the various groups, analysis, statistics, algebra, were asked to meet around about January, February, to discuss amongst themselves what courses they would want to teach. And there was never really any fighting. And so we would decide, well, I'd like to teach stochastic processes. I haven't taught that, and you've taught it for 3 years. Introductory statistics 203 or probability theory. And that's the way we arrived at the courses.
And
that
you stay at it for 2 or 3 years then maybe?
Yeah. And in some departments I think people teach them for 10 years. We never had... Mathematics tends to be different in that sense. No one owns a course.
Gotcha. Yeah. And which were your favorite? When would you try and fight to have particular ones yourself?
All right. So I really enjoyed. So everyone sort of wanted to teach the honors students. Yeah. Because the classes were smaller. Yeah. the honors probability course that I taught on a number of occasions, 16, maybe 20 students. Yeah. I think it's now near 60, 70.
Oh,
it's completely out of control. Yeah. So they were really fun to teach because the students, many of the students, were incredibly smart.
And you probably had a hand in directing them on to study later on.
Well, as you know, Jim, that's one of the joys of teaching, of seeing how your students turn out and being able...
Picking out the good ones, right?
Picking out the good ones, and it's not always easy to tell because students can be look incredibly good on paper and then turn out not to be successful. But apart from the honors students, surprisingly, I enjoyed teaching the service course, Math 203, because, very large class, high school algebra, the only prerequisite, but many of the students were very smart. They were future medical students. They wanted to get into medical school. And even until very recently, before I retired, it was a lot of fun teaching a course like that because that's where you learn the subject. You can't hide behind theorems.
That's right.
You have to understand the subject. So, and then survival analysis, I sort of
Yeah.
enjoyed teaching that.
It was kind of special. I think.
Yeah. As I said, most courses become enjoyable if you feel you're learning something.
Yes.
Strange thing to say from a teacher, that you're learning something.
Yeah.
But
it's a humility, I think, that you need, right? Yeah.
Humility, and every now and again, you must have had the same thing. A student would ask a question, and you'd say, I've been teaching this for 40 years, and no one's ever asked me that question. I've never thought of that.
Well, there's one I learned the other day, David. I'll reverse things for a minute. I had been teaching for years that the standard deviation is the square root of the squared deviation.
Yeah.
But you could estimate the standard deviation by asking everybody in the class to say, are you above average or below average age? And just keep track of the absolute deviations and average them. And I said, it'll give you close to the same answer without going through all the thing. Well, I did a little simulation the other day, and it turns out you get about 80% of the standard deviation if you do it that. And I haven't understood it. I had to look it up on the web. I'm too old now.
Yes.
And so I couldn't believe that for 40 years I had misdirected them about it. Yeah. And you're right. You can still learn at this age. It's something else. Yeah.
But Jim, here is a question. Again, maybe a bit technical. Maybe a bit technical for this, but here it goes. So this student asks me, I'm talking about conditional probability.
Yeah.
And I did an example. If you're drawing a red ball, you're doing balls from an urn that contains red and green balls, and you're drawing without replacement.
Yeah.
So I said you could do this problem in two ways. You can do it by counting, permutation argument by counting, or you can do it. So I said, what's the probability of getting a red ball on the fourth draw?
Mm-hmm.
And so, or you can do it by conditioning backwards. Probability of getting red, given the various things, and you sum over all the probabilities of the various options. Conditional probability. So I said, it's much easier to do it by conditioning, because each of those little component probabilities that you calculate is very easy.
Okay.
Whereas you feel always shaky when you're dealing with permutations.
Absolutely. You've missed some, or you're overcounted, or
So there are two ways. So then the student puts up his hand and he says, well, how do you know that they will give the same answer? Because, he says, one of them, the idea of counting, just involves the basic notions of probability, just uses the axioms of probability. And the other one, conditional probability, involves an arbitrary definition of conditional probability along the way. Why should they be the same?
Oh, my goodness.
And so I thought that was a really amazing question. Why should they be the same?
Yes.
Because one involves a definition, only occurs somewhat into the story. You give this arbitrary definition of conditional probability. Why should you get the same?
My goodness. Yeah.
Anyway, we won't go into this. I can speak to you some other time, but I think I know the answer to that. But that sort of question, which is, it impresses me. It doesn't impress me when students put up their hand and say, well, couldn't you think of this as a locally compact Hausdorff space? Because they've learned it in some other course.
Yes, and parity.
Yes.
Yeah. The other one that always impressed me, David, and I had it wrong, and I had to go back to you a couple of years ago about it. You used to do the one where you could tell which students had made up the 200 coin tosses by faking it.
Yes.
So you asked them to what?
So I say to students, go home.
Yeah.
I wouldn't tell them anything. Go home and toss a coin 200 times, and write down the outcomes of your tosses.
The sequence.
The sequence. I want the sequence.
200 of them.
200 of them.
Yeah.
And then hand in your sheets of paper to me, and then I'd separate them and go home and separate them to two piles, and I say, you cheated and you didn't cheat.
What?
Yeah. And so the way it works is that if you toss a fair coin 200 times, the probability of getting a run of at least one run of 6 heads or 6 tails is more than 0.95.
Oh.
So now people who are cheating chicken out before they get to 6 in a row. They'll maybe get 4 or 5, but most people will chicken out. They won't put down 6 heads in a row if they've been asked to simulate in their heads the tosses of a fair coin.
So are they impressed as hell when you can basically separate the class and the fakers and the...
Well, it's not perfect. Of course, there are going to be mistakes.
Yeah.
But often, it was right. I say to them, you can use a computer to simulate the tosses if you want.
Yeah,
but I wouldn't tell them what I was going to do.
Oh, I see.
Now, this actually, I first saw this with the guy Steve Samuels, who was a probabilist at Purdue. And he came to give a talk on how you could use the computer to compute this probability. It's non-trivial.
Right. Yeah, you showed me, you sent me the proof later, and I had to look it up.
It's non-trivial. It needs a Markov chains. You can get a lower bound if you take disjoint segments of 6.
That's right.
Then you can get a lower bound, and the lower bound is 0.6 something.
Yeah.
So I can give that to the class.
Yeah, exactly. The other one that I always was impressed with, you would use your own money, I think, to give prizes for.
The birthday problem.
Was that what you would? What would you do?
So I would say to students, all right, who is prepared to bet me? I bet you that there are at least two people in this room who have the same birthday. And if you win your bet, I'll give you $1. Otherwise, you give me $1. Now, if it was a very large class, I would just say I'm going to take the first 30 people, the front row, and ask them their birthdays. And if it was, otherwise it could be the whole class. If it was an honors class, there may be 20 or 25 students. So there went many years, Jim, many years, I didn't lose the bet. Mm-hmm. In my final 3 years, I think I lost the bet 2 out of 3 times. There was one occasion in an honors class when I wrote down all the birthdays on the blackboard, and it looked like I was going to lose, and someone opened the door, came into class late, and I said, "When's your birthday?" His birthday coincided.
I see.
But then, I was very smart. Jim, I was very smart. I knew how to get the students to like me. When I won the bet, and the person would come to the front and give me their $1, I'd say, "Oh, don't worry about it."
Oh, I see.
See, I knew.
The separate one I asked about money was that you used to give $10 for students to come up with solutions.
No.
I thought I remembered the students told me that you had put up $10 for a solution in class.
Never.
No?
I don't recall doing that. I don't recall doing that.
Well, when you had to write letters for people a lot.
Yes.
Right?
Yes.
And I imagine, I don't know if the universities pay that much attention to how good a teacher somebody is, but I hope they do. I don't think they do as much as they say.
Yeah.
What would you pick out for a good teacher? You know, what would you like the letter to be about you? You got prizes for teaching at McGill. What do you think was in the letters about you, or what would you write about others? Good teachers. You know,
well, I think a lot depends on for these awards.
Yeah.
I think that what gets an award is a letter that says something different about the person. Because I've been on these committees. I was on the Leo Yaffe committee and the Principal Prize committee. Students say, "This is the best professor I've had at McGill." These people who are put forward are usually have very high course evaluations, and students say they're great, I love them, and so on. Mm-hmm. What you need is someone who says something unusual about you. And to me, that's what counts. Is something special about them. Yeah. Having said that, I regard myself as a very old-fashioned meat and potatoes teacher. Mm-hmm. I strongly believe, that what comes out of your mouth when you're in front of the class is the most important thing. Not what you present visually, but what comes out of your mouth.
You're talking about outlook and attitude, and
what you say.
I see.
Is more important than having spectacular visual displays. I think that, to me, if I go to a seminar and I can just shut my eyes and listen to what the person's saying and understand it, to me, that's a good talk.
Got you.
I mean, an example of that, and I don't want to mention any names, but
Right.
there was someone from another department in the McGill campus, statistician. So he came to give a talk. You probably identify him, but he gave a talk on the bootstrap. Well, he put up copies of the manuscript paper that he'd written. So you think, well, this is terrible. What a terrible way to give a talk, just put up pages. But it was wonderful what he said. You didn't have to read the pages. He gave a wonderful talk. So despite the hindrance of the visual stuff, nevertheless, it was a great talk because of what he said. So,
do you still, right to the end, did you still have write on the board or on the equivalent of a board and then have the students take it down? Is that still important in teaching?
Yes. Well, and actually to students. So less so writing on a board because the classes got too big for that.
Yeah.
If you had more than 50 or 60 students,
But you'd still have them write.
doc cam. There's something called a doc cam.
Yeah.
So you write on a piece of paper and it's projected onto screens.
But they are writing down from you.
They are writing down from me, and students much prefer that than having slides because things come in discrete packages.
Yeah, I see.
And
the discipline of writing it down, are they actually understanding the steps as they write it? Do you go slow enough that they can?
I'll go to speed that they can write, that they can copy.
See why each step leads to the next.
Yes. They see the subject unfold,
Yeah.
and that's what we went to dinner with David Cox once.
Oh yeah.
Oh yeah, when he came to Montreal and he gave I think it was a survival analysis series or something, and we went out for dinner with him.
Yeah.
Jacques Hutebis, who was the chair, invited us out for dinner,
Yeah.
and Tina was sitting next to him. I was sitting next to him on the other side, and we were asking about his style of teaching.
Yeah.
He said he much prefers to write on the blackboard because the students get to see the subject unfold.
I see.
Rather than in discrete,
All in one
discrete,
yeah.
you see this, and I'm a strong believer in that. Students appreciate that.
Yeah.
It's old-fashioned, but they appreciate that.
Yeah. What do you think now about learning by simulation, for example? Do you think there's a place for that now or not?
Learning by simulation.
Yeah, learning the laws of probability and so on. In other words, let's run the sequence first, like we said in the computer, and figure out why the runs are as long as they are. Do you think or is it still better to go the other way?
It could be, but I mean, again, you want to know how old-fashioned I am? So this is how old-fashioned I am. You teaching the central limit theorem.
Yeah.
So you take a uniform. You say the uniform looks nothing like the normal.
Right.
Now you take the sum of two uniforms, standardized, and it's a triangle.
Yeah.
Now you take the sum of three uniforms and it looks this tent-shaped
right.
thing.
Yeah.
I think the students remember that more than if you put up a fancy display and you see the uniform evolve into this normal curve.
So you're saying going from 1 to 2 is already probably
To
the most
1 to
important
2 to
step.
3. Somehow,
Yeah.
I think, just drawing on the blackboard,
Yeah. Yeah.
those three diagrams,
Yeah.
I think sticks in people's heads more than if you put up a video.
That is true.
For some reason,
Yeah. Yeah. Laplace has one of them. And Laplace had to do the central limit theorem with a sum of 57 uniforms. And he said, I gave up at 12. He gave up at 12.
Wow.
He had a formula for the whole thing.
yeah.
Yeah. But interesting.
I think the great thing with teaching is preparation. That's the most important thing. You have to prepare. You can't wing it.
Yeah.
You have to learn what you're going to teach, as if you're an actor.
Right.
But you don't make it sound as if it's rehearsed.
What would you do about things like opening with a story? You know, a vignette or something.
Absolutely,
How
yes.
does that work?
Well, absolutely.
Because I've tried, but I waste a lot of time on that, and people remember the stories, but then we never got to the.
Yeah, we call them anecdotes. I love to give anecdotes, and my idea was I would give an anecdote in class every time, so that students would try and have something every time. They could go away and say, "Well, that was neat. I learned that was an interesting thing."
Mm-hmm.
Try to make every class have an interesting thing, and the anecdote was the vehicle. Well, the mistake I made for a long time was to give the anecdote at the beginning of class, because then it dragged, instead of being 5 minutes, it dragged into 15 minutes and half the class was gone. The trick is to do it at the end of class.
I see.
And to know exactly what you're going to do.
Yeah, have the clock stop you.
Yeah.
Yeah.
So you could tell stories about, say, the O.J. Simpson trial.
Oh, I know you spent a lot of time at home watching the O.J. Simpson.
Oh, yes,
trial.
and I tell them that. Yeah, students love that sort of thing, how we used to sit in front of the scrambled picture because we didn't have cable, watching CNN. Tina and I would sit up the dinner table.
I remember you going home and you couldn't be found when that trial was on.
Yeah.
What do you mean the scrambled TV?
So we had CNN. We didn't get CNN on our TV. Only got a scrambled picture. So the preliminary, it was a preliminary trial.
Yeah.
Preliminary hearing. We'd set up the dinner table in front of the scrambled picture and just listen to the.
Oh, I see. And who was it that was doing the expert testimony? There's some statistician.
Terry Speed.
Did he get it right or did he get it wrong that time?
Terry Speed was.
This is Stuart about the, by the way, about the glove and the blood, isn't it? Mainly.
Yeah. Well, Terry Speed gave, and I disapprove of this, but he gave evidence for the defence, and I really don't like that. Who was the guy? I forget now. Who was chair at Washington and who was at NC State. Name just don't recall, but he gave evidence for the prosecution.
Okay.
And it was on blood evidence.
Yeah, it had to do with
So-
the match and the blood.
Yeah,
and
so
the
it's-
glove, I think, right?
Well, it was there wasn't. I don't think it was a glove at that stage. It was maybe in the Bronco
Okay.
or at the scene. So he gives evidence, and the next day he's cross-examined.
Yeah.
Now he has evidence as 1 in 100,000 chance that someone else in the community could have the same blood as was
Right.
found at the scene. So he's cross-examined by the defence, and turns out that he's made a mistake.
Wow.
It's combinatorial because it was a mixture of
Well,
three
it's going
different.
back to your counting.
Yes, it was 3 different blood stains mixed together,
Oh.
which made it harder. So, as the defence is quite entitled to do, they didn't say, so all these calculations are wrong. Now we move on to exhibit number 30, exhibit number 32, exhibit number 33. So they took them one by one and said they're all wrong.
Oh my.
So Judge Ito was very annoyed, and he sent to this guy, the expert witness, who's a geneticist, a statistical geneticist, I think, said, you go home and fix these. So he came back the next morning, and he had fixed them. Now, it turns out that when he fixed his calculations, the odds were not nearly as strong. It was 1 in 800 or something, is not 1 in 200,000. So it ended there. It didn't end there. Subsequently, as you know, there was a civil case, a civil trial.
Yeah. There, the balance of probability only needs to be 0.5,
Yes,
right?
called the same guy,
Yeah.
prosecution, to give evidence. Turns out that the second time that he had supposedly corrected his mistake, it was still wrong. He had made a mistake the second time, which was discovered in the time in between the criminal trial and the civil trial. What happened is he said that he was called to give evidence at the last moment in the criminal trial, and he hadn't had a chance to do the calculations properly. And in between the two trials, he had programmed it on his computer, and he had corrected it.
Would you tell any of that story in any of your classes? Or that's too long-winded, I guess. Too complicated for a class, is it?
I don't remember if I ever told that story.
Yeah, but I do remember you going home to watch the pieces.
Yeah, it goes to show. But you and I would be much more tolerant. So he made a mistake. It wasn't that It wasn't a fundamental thing, it was a counting mistake.
Okay.
But of course the ramifications were huge.
Yeah, exactly. Now, the papers and topics you've had done research in,
Yeah.
survival analysis is one. I imagine if I asked you what your most important chunk of work was it to do with the length bias?
Yes,
Yeah.
yes. And I think that was...
How did that start?
So that started because Tina had been involved, one of the PIs on the Canadian Study of Health and Aging.
Yeah.
And this was a study looking at the prevalence of dementia, one of the main goals in Canada. And so she said they had these data. They started with a cross-sectional study.
Yeah.
10,000 Canadians were interviewed.
Yeah.
And then they identified those who had prevalent dementia.
Yeah.
Of various types.
Yeah.
Alzheimer's disease, vascular dementia, and various other dementias. And then this cohort, everyone was followed actually for 5 years.
Yeah.
And they identified when some of them had died. But the important ones were the ones, for our study, the important ones that we were interested in, or Tina was interested in, is the 800 who were identified with either probable Alzheimer's disease, possible Alzheimer's disease, or vascular dementia. How long they survived from onset.
Yeah.
But she didn't know how to deal with the fact that she had prevalent cases.
I see.
And so she thought, well, she could just take those who had onset within 3 months of 1991 is when they did the first cross-sectional survey. But of course you would be throwing away a lot of your data.
Yeah.
So she asked...
Because there's a big backlog.
Yes, there are many more that had onset before 3 months.
5
Yeah.
years ago, yeah.
So Masood, and she asked us what we would do, and Masood and I looked into it, and we realized it was this phenomenon of length bias. So we thought, oh, well, we would look into this. It probably hasn't been done by many people. And of course, the pile was this high of people who had worked on length bias. Oh, yes, a huge number of people.
Yeah.
But
this is a very new twist, a new application.
It was a new application. So what we found in the dementia literature, that people had either recognized, if you took prevalent cases, that you would have this phenomenon of length bias, but hadn't accounted for it, or simply hadn't accounted for it. They just didn't realize. So they were getting a median survival of up to 9, sometimes 12 years.
Yeah.
And when we analyzed the data properly, and when we analyzed the data properly, we found a median survival of about 3.5 years.
So they were off by factor 2 to 3.
That's right. So previously it was 6 to 9 years, or 6 to 12 years.
That's what I think of. 7 and 3.5 is the numbers I remember. Yeah.
So we just had to decide where we were going to submit this. And I said, well, what about the New England Journal of Medicine?
Yeah.
And Tina said, you're crazy. It's never going to be published there.
Yeah.
Well, not only was it accepted there, it was the lead paper, and it was accompanied by an editorial. And for the week afterwards, Tina was getting calls from all over the place, in Australia, in networks.
Had the what's the word? The medical community themselves, did they know that the 7 was wrong? Or had they any sense of it, or were they being fooled as well?
Oh yes, a lot of the authors of these papers were clinicians, and so they didn't realize. And even now, I would think
that you're seeing a funny sample when you see it from the back end. I guess.
Yeah,
Is that it?
yeah. Well, that's right. They didn't. They thought, well, I'll just go back and look when onset occurred, and I'll look and see when people survived, when people died, and that would be. They didn't realize it was a biased sample. But the things that made this satisfying. So here was this work that we had started out looking at theoretically, and we had this in a very prestigious medical journal.
Yeah.
At the same time, we had developed the statistical methods to deal with the specific type of data. It was length bias in the certain technical sense.
Yeah.
So no one had done this.
Yeah.
There was a certain.
That was the whole area you broke open.
Yes. We broke open
Yeah.
this area. So we ended up publishing my student I and a PhD student publishing a paper in JASA. And to me, that is the ideal for a statistician. You get to publish your methodology,
Yes.
and at the same time,
Yes.
there's something substantial.
The
clinical
influence
importance.
was big. Yeah, very big.
And that, to me, is the most satisfying thing.
It must be, yeah. I still drag out that paper and show it to students and ask them about the 7 years and the 3.5. And
Yeah.
I can't believe that people missed it.
Oh, yeah.
Yeah,
Even now, I think that there are people who probably miss it.
yeah. So that was very sad. And then you did a fair amount of theoretical development, I remember. After.
Yes. After that, then
Yeah.
of course it becomes
Nail
an
things down.
industry, and other.
Like everything.
Yes, it's like
Yeah.
everything we do.
Yeah. I came across, and I've sent it to Masood, a reference from Francis Galton, who was looking at how fast people could get through sailing the Atlantic from west to east, and all the captains had kept, when they finished their voyage, they would hand in their logs. And he realized that if you spent so long in a windy place where things were going fast, you could get through the zone
Yes.
faster than others. So Masood is now looking into the fact that this was recognized in 1870,
Huh.
that the calculations were all wrong, because if you spent a long time in a zone where there was no wind, you were there too long.
Yes.
I think it overrepresented
Huh.
things. So it's been going on a long time, but in all little pockets separately, I think. And of course, there was no name for it. But you weren't the first one to come up with the word length bias, were you?
Oh no, not
No,
at all.
that
Not
was
at Cox. Cox, actually, whether Cox actually was the first, I don't know. But certainly Cox talked about it in one of his papers, and his interest in length bias was the following problem. Very interesting. You have a stretch of material, textile.
Yeah.
Because he was in the textile industry in Leeds.
Yeah.
And you want to get the distribution of the length of the fibers in that piece of textile.
Yeah.
Now, this is really applied statistics, right, Jim?
Absolutely.
How do you do it?
Yeah.
So he said what they did is they pinched the material, that stretch of material in the middle,
Yeah.
and then they combed out
I see.
the fibers that were not pinched, and they looked at the length of the fibers that remained.
I see.
And they had length biased fibers because the shorter ones are not going to be pinched.
I see. So that's where it came from.
That's one of the first.
Cox definitely was in the wool business at the beginning
Yeah.
in Leeds, I think.
Yes, yeah.
In the 50s and 40s,
Yeah.
probably. Interesting. Yeah. So I'm just looking at the time, and maybe we'll take another, 10 minutes maybe?
Yeah,
Is that
10,
okay?
15 minutes, yeah, sure.
Yeah. Just want to you didn't ever think of writing a book, did you?
No,
No.
I've been approached several times by publishers to write a book. No,
Yeah.
I think it's a make-work project. They come out of date very quickly. It
Yeah.
requires, it has to be perfect. You go through it again
Yeah.
and again and again. It's just, I didn't.
Yeah, exactly. Now, just a couple of short answers now on a number of topics that we'll pick the ones, whatever. When you taught or whatever, did you fuss about corrections for multiple testing? Would that have been a hobby horse of yours, one way or the other?
It never came up in the courses that I taught, really. I may have mentioned it, but it was not something that
Okay.
that came up.
P-values, were you for them or against them, or do you still you know the concern that there is now about statements in the ASA and so on, and significance and so on. Is it overplayed, would you say?
Right, so I think p-values, so there are two different things.
Yeah.
Should you report p-values or shouldn't you report p-values?
Right.
Let's put that aside.
Yeah.
If you're going to report p-values, what do you think? I think a lot of people report p-values. I don't think every journal has banned them. Maybe epidemiology, maybe, I don't know about the American Journal of Epidemiology. But since everyone is still using them,
Yeah.
I think you have to understand what they say. And so I spent a lot of time in my introductory course saying what a p-value is
Yeah.
and what a p-value isn't.
Right.
And so I think it's important to understand that. And I gave, a year or two ago, gave a seminar on a paper written by Val Johnson and others, which was published in the Proceedings of the National Academy of Sciences, saying that when you are looking at a new finding,
Yeah.
say new drug,
Yeah.
your P cutoff point should not be 0.05, which is completely arbitrary, but be 0.005.
I see.
Because Valen, being a Bayesian, says if you look at the posterior odds
Yeah.
that there's a difference between these two treatments, you'll find it could be quite high, and only three times as much chance that the new finding is correct if you cut off at 0.05.
I see.
So the idea is that you should make your p-value much smaller in order to be consistent with what a Bayesian would do, which of course is Bayesian is looking at the probability that the null hypothesis is true
Yeah.
relative to the probability that the alternative is true, or vice versa. But I always tell my students, you must understand that a p-value represents the proportion of times under the null hypothesis that you would get something as extreme or more extreme than the one that you've got. It's about the procedure.
Gotcha.
And it's all of this is something I love to emphasize to students. If you're a frequentist, everything you do is a reporting of the procedure.
Yeah.
It's not about what you have found today.
That's right.
You're happy about what you have found today only because the properties that your procedure has. And that's what statisticians have
And
devised.
That leaves out then all your other knowledge, of course, right?
Yes, of course. And that, of course, is completely different from the Bayesian approach.
Did you kind of convert to Bayesian approach later on? Or?
Never really converted, but when Lawrence Joseph, who was a colleague of yours,
Yeah.
he did his PhD with me, and when he finished, or was about to finish, we decided to read through Jim Berger's book on Bayesian inference and decision theory, and became interested. I became interested in Bayesian inference, and of course Lawrence became a Bayesian fanatic,
Yeah, champion, I should
a
say.
champion of Bayesian methods.
Yeah.
But I think I have the attitude of Cox. I mean, maybe it's too much to compare myself with Cox,
Yeah.
but Cox describes himself as a pragmatic statistician.
Yeah.
Sometimes if Bayesian inference is convenient,
Yeah.
he'll use it, sometimes not. He wouldn't.
But now big data is becoming very big now. Are you skeptical, or you see promise for all that's being held out for big data?
It's such a big catch-all terminology,
Yeah.
and the big problem is, where does the data come from? There's very rarely the case that design has gone into it. But I don't think it's going to disappear. It's probably going, as computers become more powerful, as we collect more and more data. Big data.
You went back, Julian, to genetics. Has genetics oversold itself? Is that your impression in genetics?
I don't have the expertise to say whether that's the case.
I think we'll skip, but I'll just mention in the record that David was chair for, 4 years in the department?
4 years. I stayed an extra year because the incoming chair
Yeah.
wanted to take a sabbatical. Yeah.
And what were your principles in dealing with people? Were people the hard part to deal with, or the students, or was it a tough job, or?
Being a chair
Yeah.
is
Something I ran from. I never wanted to be.
Being a chair, first of all, you are owned by the department.
Okay.
One should not think that you're going to be chair and then you'll do what you normally do and just come in once or twice a week and take care of things.
I see.
I always got the feeling that I was owned by the department. If I wanted to go to the bathroom, I had to say I'm going to the bathroom. If I was going to go out of town for a few days, you had to tell the department you're going out of town. So
things matter. You
yeah,
need to be around.
you need to be around, and you, as I say, you're owned.
Yeah.
Secondly, it's a job of putting out fires.
Okay.
You may think, oh, this chair has been really unlucky. This is what happened under their watch.
Yeah.
believe me, it doesn't matter who you are, there will be at least one, probably many more fires that you will have to put out along the way.
Yeah, yeah.
Sort of thing that happens is before the calculus exam, probably thousands of students writing it, you hear that it's suspected that students might have got wind of the exam.
Right.
What are you going to do the night before? That sort of thing.
I see. Were you disappointed by people, or they were okay, mostly?
So someone told me,
Yeah.
when you become chair, 95% of the problems are caused by 5% of the people. That's true.
Yeah,
My colleagues were mostly very cooperative.
yeah.
They were prepared to help out.
Did you lose any friends along the way?
No,
No? Good.
no, but but on the other hand, then I wasn't editor of a journal.
That's a nastier place.
I believe.
I see.
That's what Tom Lewis told me.
Yeah,
That I think when he was editor of JASA, I think,
okay.
and he said that he was told that he would make many enemies. You know that, Jim. I mean,
Yeah,
no
yeah.
one wants to get a letter from the editor
No,
saying this
No,
your
and
paper's
you could have- you
rejected.
could- that's right, that's right. And you were mean. And
But my
you were
colleagues.
a censor. Yeah.
But I have no problem with my colleagues.
Yeah. And now, quickly, what are you doing now that you're retired? Has life changed, or you're still listening and learning? And
Yeah,
are you going to stay? Are you going to stay involved?
Yes, absolutely.
Yeah.
I still have my office. I've been given my office, but it's
Yeah.
in danger of being taken away, I guess.
Yeah,
Because of COVID, I haven't been in
yeah.
very much.
But you
But I have.
sitting on
I'm,
seminars?
I'm sitting on seminars. I'm doing research.
Are
fact-
you collaborating with your son?
Yeah, we just had a paper.
Is that right?
Well, one should never say it's accepted, but
Yeah.
it's going to be accepted.
What-
It's just
what topic?
it's on mixing incident and prevalent cases,
I see. From
survival
the-
survival
so
analysis.
kind of going back to the aging stuff.
Yeah, that's
see.
one of the examples that we used.
I see.
And so that's the second paper that I've written with Julian.
Oh, okay.
And he's not. I mean, there are other authors on the paper as
Yeah,
well,
yeah,
but
yeah,
which is nice
yeah.
to think that.
Have there been any yet with the three of you?
No, that's one of our
Come
goals.
on, you've got to do that.
Yeah, that's yeah. And so I'm still doing research, absolutely. And a PhD student just finished 2 or 3 weeks ago.
Okay. Are they in transit?
No. He's my last student.
Yeah. Oh, good. What would the advice that you give now to new students be different from what it would have been 40 years ago? Is it a different world out there for statisticians now, trainees? Do they have to know mathematics in a different way, know computing in a different way?
Well, they have to know computing in a different way. But if I may, Jim, I mean, maybe this would offend your sensibilities, but
No, nothing.
you remember when we had the biostatistics conference in Montreal?
Yes.
So Norm Breslow was sitting on the stairs
Is
at
that
lunch.
about the IBC?
RBC.
Yeah, I was one of the organizers.
So Norm Breslow was sitting on the stairs at lunchtime.
Yeah.
And I heard one of the students from epidemiology and biostatistics go up to him and ask him, what should I do
I see.
to learn more epidemiology and statistics?
Yeah.
You know what his response was?
No.
Learn more theory.
Oh yes. He sat in on Wellner's courses later on.
That's right. So let me tell you about that.
Yeah.
So now you have Norm Breslow.
Yes.
I attended a lecture of his at the Statistical Society of Canada, and he was talking about Wilms tumor,
Yes.
because that was his
Yes.
applied area,
Yeah.
Wilms tumor.
Yeah.
And I sat there in the audience thinking, this is a ridiculous talk. It should never be at this conference. It should be at a medical conference, because I can't understand anything he's saying.
Mm-hmm.
It's so medical.
Yeah.
And then, not long after that, I attended a conference where he gave a talk on the work that he'd been doing with Wellner.
Yeah.
Highly theoretical talk, and I thought, this talk is way too difficult to understand. It's too mathematical. So, but there you go, Jim.
Yeah.
That's what statisticians, that's ideal, is
They
it?
need to be switch hitters.
Absolutely.
I think that's what's harder now. Yeah. And somebody told me once that asymptotics do matter nowadays.
Yeah.
And I always said that asymptotics didn't, because who cares? Everything goes to normality asymptotically.
No.
And Alain said to me, no, Jim,
No.
the new genomics and the new big data, watch out. You'll have problems. Right? Yeah. So what do you say to students then to finish off with?
Well,
First of all, there are jobs in the area, right?
Yes, I say you should. I mean, when choosing a topic, a supervisor should choose something which is going to be useful.
Yeah.
Don't choose some esoteric area.
Yeah.
So I'm not saying students should do their degrees in probability theory. I wouldn't advocate that because there are a limited number of jobs in probability. You are competing with mathematicians, analysts, and so on.
Yeah.
I said if you want to be a statistician, you must be interested in applications. That's what I tell students, and that never used to be the case.
I see. And you yourself, I guess, are an example of it, right?
Absolutely. I was.
Transition.
My PhD was in limit theorems for semi-Markov processes.
Yeah.
You could call it applied probability. It was really probability.
Yeah.
And then I quote saw the light
Yeah.
and saw there was much more to life
Yeah.
than just pushing theorems.
Yeah.
And I'm a very firm believer that you must be interested in the applications if you're going to be a statistician. You cannot anymore write at the end of your paper, and there are lots of applications.
Right.
Should
you start with them?
I learned that you start with an application, and you know who I learned from?
No.
Lawrence. So Lawrence and I wrote papers at some stage, and we used to say there must be thousands of applications.
Mm-hmm.
And then we'd spend half our life trying to find the application.
Yeah.
Lawrence said to me, David, we're not going to do that anymore.
Good.
We're going to start with an application.
That's right.
Start with the problem, and then develop the methodology.
You're very much, I'm on the same wavelength. I said we have already plenty of other things. Yeah, there's enough problems looking for solutions, right? That's what you're saying.
Yes.
Yeah.
So, Jim, if I can ask you a question.
Yeah, sure.
So, this is what I believe, and I ask your opinion on this.
Yeah.
What I would love to do is to have access, and this is hypothetical, have access to the data of big findings in medicine, say, in the medical field.
Yeah.
So there have been big findings, big discoveries made, have access to the data, and see whether a simple statistical analysis would have come to the same conclusion as perhaps the fancy analysis was used. I would just wonder, I'm not saying this, but I just wonder whether all the machinery we statisticians develop is all that necessary, and whether often you would have come to the same conclusion with something relatively simple.
Yeah, I've been interested in that topic too.
Wouldn't it be great if you could do that?
One of the things I asked people, I think it was Tom Lumley I asked, probably.
Yes,
Tom
he's
Lumley.
in New Zealand now,
Yeah,
I think.
that's right. And I was there and asked him, I said, the same thing, if we go back 200 years ago to the medical journals, where they figured out something, right? Did they have more data in order to be sure of things? Because today I think we're cutting and trying to get there faster, being more efficient with our procedures. Did they have more data? And he said, oh yeah, they had a lot more data. And then his example to me was, look at the reliability of bridges and roads. Why have the Roman roads and viaducts lasted 2,000 years? It's because they're over-engineered, because they didn't have the theory that we have today that would say you can cut this and you can cut down this concrete by this percent and you'll still be okay for 100 years. So that's his. But I had the same, I was thinking of doing it at one point, going back to some big things in history. Right? Like it could be Rutherford and the atom. It could be others. I think they had more data than they needed. That's my own impression.
Yeah, but it's not only data; it's the statistical methods.
Well, right, but I think if there's enough data.
Yes, the data
are the model.
Absolutely.
Right. I think that's it. Yeah. Anyway, David, I think we'll wrap up, but I have to let you go. We could talk for a long time.
Yes.
And I think maybe we'll do another. Maybe we'll do the sequel in next year. But I'm delighted to see this and to hear you firsthand, and I hope our listeners agree. And so thank you very, very much for making statistics and teaching so enjoyable, and our profession, I think, is in good hands. Yeah.
Well, thanks very much, Jim, and I enjoyed it as well, but I'm sorry we didn't get to cover nearly a fraction of the topics that
we'll
we could have done.
We'll do the sequel.
Yeah.
Okay? Thank you.
Okay, thank you, Jim.